So we're going to look at exponentials, specifically how we can convert from this form into our natural E, our Euler's numbers form. We've come across these before, but just in case we're not familiar, what I've got here is $100, let's say $100, and it's multiplying, it's doubling every time period t. We might that time period t equal years, so this would be $100 doubling every year. After 1 year, we'd have $200. After 2 years, we'd have $400. After 3 years, we'd have t equals 3. 2 to the power of 3 is 8, $800. You can see that pattern continuing. So what we're trying to do is convert that into our new form where we've got E instead of our growth base. So here we can see that we're doubling, whereas we're using a different technique. It works exactly the same, it just looks a bit different. So what we're trying to do is find properties of this that align with the variables that we don't have values for. So we'll start with the number at the front, okay? We can see that this here is probably going to associate with the 2t, and the A is probably going to associate with the 100, but let's find out. We can always let t equal 0. Okay, we can do that for both. Now because these are the same equation, y will equal the same thing. We could even sub them together, but we won't, we'll do this way instead. We know that anything to the power of 0 is 1, so we get y equals 100. Now we can shove that up into this part here, so we get 100 equals a e to the power of k times 0. K times 0 is 0, so we get 100 equals a times e to the power of 0. E to the power of 0 is 1, so a equals 100. That's quite simply our initial amount. So these are both our initial amount. And we know that because anything to the power of 0 is 1. So now what we've got to do is try and convert this 2 into something here. Now we can see that they've both got the power of t, so 2 is likely going to be equal to e to the power of k. Because I'm just going to put the t in now. They are exactly the same thing, correct? So we can see that 2 equals e to the k. Now the way that we isolate or get that k into a position we can attack is to use our logs. What we would probably do then is ln e to the k equals ln2. And we can apply our special log law, our log law. We plonk that out the front. So now, I'm just going to do this over here. Now we have ln2 equals k times ln e. Now ln is the natural log, which means log base e, which means that we know that this equals 1, because log base e of e is 1, so now k equals ln2. Which means that this is true. What I'm about to write is true. Why? I need some room. Where am I going to find it? I might tilt the board. I've got some room at the bottom here. Here is what I'm trying to get at. Y equals 100 times 2 to the power of t is exactly the same as y equals 100 e to the power of ln2 t. They're exactly the same thing. They represent an exponential growth. All that we've done here is replace e to the power of ln2 with the number 2. It's the same thing. We need to be able to do both. We need to be able to deal with both this form and this form. Particularly powerful when we're deriving, because we can derive these types of functions. We struggle a bit more with these right now.